Hi, hello, welcome to Knowledge Center. In this session, let me explain you how to write a program to transfer the data serially in Microcontroller 8051. In my previous video, I have explained you the basic information required to do the programming in serial communication. So now let us begin with the procedure of writing a program. See, every program will have its own flowchart. Same way, here in transferring the data serially, we have to follow few steps. Let us see what are those basic steps required to write a program. If you understand these basic steps, then the same steps has to be applied for any program wherein you are transferring the data. So let us begin with the step number 1. See, as we know that while transferring the data, we need to make use of a baud rate. So before transferring the data, you have to set the baud rate, means at what rate you are going to transfer the data. And how to set that baud rate? By using timer 1. So first you need to make a settings that we are going to make use a timer 1, that too in mode 2, which is in auto reloaded. So this concept has been explained in my previous video. The link is given in the I icon over there. You can press it over there and watch the previous video. So to select the timer 1 in mode 2, we have to make use of tmod register. If you have forgotten about the tmod register, you can have a register here. I have written it on the board, and also if you want to have a detail about the tmod register, then click that I icon, you will get the link. So let's see, in this tmod register, this is for timer 0 and this is for timer 1. We are not bothered about timer 0, we are selecting timer 1. So let us make all these bits of timer 0 as 0. All 4 bits means low nibble will be 0. And here I want timer 1, but that timer 1 should be in mode 2. So these 2 bits M0 and M1 are used to select the mode of the timers. So if you want mode 2, then what you need to put here? If I put 0, 0, it will be mode 0. 0, 1 means mode 1. So I should put 1, 0 here, which is going to be a mode 2. And remaining these 2 bits has to be 0. So this is what the data you have to enter into tmod to select the timer 1 in mode 2. So step 1 says that enter the tmod value as, what is this value now? 0, 0, 1, 0 means this is 2 and this is 0. So you should enter 20h into tmod. That is the first step. Okay. So what's happening there? We are selecting that timer 1 in mode 2. That is very first step. So after that, after selecting the timer 1 in tmod, you have to enter the value into the timer which will decide the baud rate. So I have mentioned some tables here. So generally we use these baud rates. So 9600, 4800, 2400, 1200. Any one among this we need to use it as a baud rate. So if you want to select 9600 as a baud rate, the data which you need to enter is -3. So you need to enter this -3 into TH1. So what is this TH1? Because we are using a timer 1. In that timer 1, TH1 and TL1, those are the 2 8-bit registers we are going to get. So if you want to know what is the TH1 and TL1, if you are not clear about that, again go to the I icon. There again I have provided a link of timer where you will understand what is this TH1 and TL1. I hope at this stage you already know that. Okay. So TH1 and TL1 is nothing but, in that timer 1, it is actually 16 bit. So we are splitting it into 2, TL1 and TH1. And data where you need to give the data is TH1. So enter the value into TH1. So you need to give the data into TH1, and that data is to be any one among this, -3, -6, -1, -24. So based on what value you need to select as baud rate. If you want to select the baud rate as 9600, then put -3 into this TH1. So this is step number 2. Put the value which is going to decide the baud rate, and where you need to enter it, it should be in TH1 only. Okay, so these 2 are fixed values. Next means only this value will change. Next, after entering the baud rate, okay, now we have decided the baud rate, right? So after that, you have to select a major concept here, that is in S mode. Okay, so in that S mode register, we have a special register which is used for a serial communication, that is SCON register. Sorry, it is SCON, serial control register. So in this register, we have to make a decision that which mode you are using for serial communication. So in my previous video, again I have explained about this SCON register in detail. There I told you that 0, the S mode should be 1. The mode what we are using is mode 1 in serial communication. Okay, when you use mode 1, the 8-bit will be framed with one start bit and one stop bit. That's what the framing you need to do. So that framing will be done when you select mode 1. So how to select mode 1? You put this as 0, this as 1. And then SM2 is nowhere related to us, so we'll put it 0. Again, this bit is important, REN, that is receive enable. Okay. So I have completely explained about this register in my previous video. If you have not gone through that, go through the description and also go through the I icon. There the link is provided. Okay. So here REN, what should be entered in REN? It has to be 1. If it is 0, it will not transfer any data. So it has to be 1. And rest of the bits are 0 because these are not used and these two are going to be high by the system. We are not making it high. So this is the data we need to enter if you want to go for a serial communication, whether it may be transfer or receive. So first you should select it in mode 1 and then make this REN high. So what is the data we entered here? 0101, it means 5 and this is 0. So we have to enter in third step, you have to enter in SCON the value what we have entered here, that is 5 and 0. So it is 50H. 50H is the value has to be entered into SCON register. So it looks very simple. So these 3 steps has to be followed whenever you want to write a program for serial communication, whether it may be receiving or transmitting. Okay, these are the basic steps you need to follow, right? So after this, okay, now we have transferred, we have made all these settings here. So fourth step, what is the fourth step is you have to start the timer. Means now we have made the selection of timer in a mode and we entered the baud rate value. Now you need to start counting it. You need to start the timer. So when you start the timer, then only the data will be transferred. Unless and until you don't start it, it will not move. So how to start the timer? Just make that TR1 high. This is the fourth step. Fourth step is to start the timer. So which timer you need to start? Timer 1 or timer 0? We have selected timer 1. So you need to select timer 1, that is TR1, and make it high. So how to make this TR1? Where do we actually get the TR1? We get this in TCON register. So in this TCON register, only these 2 bits are for timer 1 and these 2 bits for timer 0. So you make this bit as high. And this is a bit addressable register. So this is a bit addressable register. So I can just use one instruction called set B TR1. If I write this, only this bit will become high. Don't worry about the other bits. Don't put anything into the other bits. Just make this as high. So by using this line, I can make it high. So when you make this high, then the system is ready to transfer. The bytes will move now. Okay. But it is ready. It's just like we have loaded everything. The bus is ready to move. The bus, even if it has been injected, means the key is on. The bus is in on mode, on condition. Only the thing is the passengers has to be filled. Then only we can move. We can't take that empty bus to the some other station, right? So now the passenger has to be filled. So passenger in the sense what here? Data. The data has to be filled. So where the data has to be filled? The data has to be filled into the S buffer register. So that is, you need to enter the data which is to be transferred. Enter the data which is to be transferred. That data where you need to enter? Enter it in S buffer. So after starting this, you enter the data which is to be transferred into S buffer. Okay. So before doing this, we have to do one more thing, that is clear the TF1. So this TF1, that is transfer overflow flag. So you need to clear it. You need to make it 0. Clear in the sense you have to make it 0. So what is, I'll tell you what is this. See, TF1 is nothing but whenever the data is transferred completely, after completion of a one transfer of byte, the TF1 flag will become high. So when it is high, it indicates that the data is transferred. Next, again, if you want to transfer another data, then you can put it into S buffer so that it can transfer it. Okay. So this is just an indication. So initially we will make it 0, and whenever the data is transferred, it will automatically become high. Okay. So now after clearing, the 6th step is to enter the data into S buffer which is to be transferred. Okay, after entering the data, and as we have started the timer here, whenever you put some information, some data into this, it will start transferring. So after transferring, you have to say there is 2 bytes. So after transfer of 1 byte, you have to enter another data into this S buffer. So when, at what time you are going to do that? You will do that only if this TF1 is become high. Because when TF1 becomes high, it indicates that the first 8-bit data is transferred. Okay. So meanwhile, while transferring this, what you need to do is you have to check for this TF1 whether it became 1 or not. You have to check for that. So 7th step is to check for TF1. Okay. So how to check? By using a jump no bit instruction, JNB TF1, and I'll put some label here. I'll put some label, and that label will be written here itself. So jump if no bit. If there is no bit in TF1, I will jump here itself. So I will create a loop, and it will be in the loop unless and until this TF1 become high. Once this become high, you will come out of that loop. So next what you need to do? You have to send another data, then put another data into S buffer, then that will be transferred. Okay. So this is an important line here. We are checking this TF1 only to see that whether the first 8-bit data is transferred or not. Okay. So once this become high, it will come out of that loop. And here what you need to do in step number 8 is, if you want to transfer any another data, then jump back to step 5. Okay. You have to jump back to step number 5. Here, I will jump here. Means again I will clear the TF1. So once you clear, it indicates that okay, I have cleared and I am transferring. Again I am coming back to step number 6. I will enter the data which is to be transferred. Then again I will check for the TF1 to become high. Okay. So if you don't clear it, it will be already high. Then that will go wrong in this line. Okay. So you have to clear it once after transferring data. Automatically the system will make this bit as high. You manually need to make it clear. So before getting another data into S buffer, we have to clear it. So I am jumping to step number 5, not directly for step number 6. So these 8 steps has to be followed to transfer the data serially. So if you want to continuously it will be kept in a loop. If you want to stop it after transferring 1 bit, you can stop it here. Okay. So I hope this is clear for you. The procedure is clear. If you are understanding the concepts, don't hesitate to press the like button. And if also you can reply it in a comment box also. Now let us take one example. I'll just take one example, one simple example, so that you can understand how we can write it using the instructions. These are the steps I have written. Now I need to execute this using an instruction. So let me take one example here. So here, let me give a question on the board. Okay. So I have written very question in a shortcut way. So you have to write a program to transfer y, that is a character now, to transfer y serially at 9600 baud rate. So our data is y, this is the character we need to transfer serially at a baud rate of 9600. So they have mentioned the baud rate. Also to send n. So this is another character, another data which is to be transferred through port 0 connected to LCD display. Means we have 8051. In this 8051, port 3, we have actually 1 bit which is reserved for transmitting of data. That is port 3.1. P3.1 is to transmit the data. So first thing is serially, when you want to transfer serially, you have to make use of P3.1 only. There is no other go. So first I will transfer the letter Y using P3.1. So when we say the transfer, or when we use this transferring this pin, through this pin only it will be transferred. So how we are going to select that P3.1? By writing data into S buffer. So whenever you write data into S buffer, it will transfer it through using a P3.1 only. Okay. So this is what it says. Serially means you have to transfer it through using P3.1. That is what data is Y. Transfer it at a rate of 9600 baud rate. After that, you send n. N is another character. It has to be transferred through port 0. So again I use port 0. It will have 8 bits here. Okay. Using this, I will transfer the data, and that data is n. It is connected to LCD display. So there will be a display where it will display as n. Okay. And it has to be done continuously. This is the word important here. it should be repeated continuously. It should be in a loop. That's the meaning. Now let's see how to write a program. See, this is most important here. Before writing a program, you have to understand the question. So this is the question and this is the logic. This is the concept what we need to do. Now, let's see how to do this. So I will follow the same steps, 8 steps what we have here. You have to follow the same procedure. And the luckiest thing here is for programming of serial port communication, these for transferring of data, these are the steps we have to follow. Okay, and these 4 steps will remain common for all programs wherever you use it for a transferring of data. So let's see how to do this. First step is take the 20 into tmod. So how to do that? We just need to move 20h into tmod. So what we can do? First thing we are going to write org. So those common things I'm not going to write here. First line is to move tmod hash 20h. So 20h is the data given to tmod, and why we are doing it already I explained it. Okay, so that we can select timer 1 in mode 2. Next step is enter the baud rate into timer 1 th1. So enter move th1 comma. So what is the baud rate you need to select? 9600. So for 9600 the data has to be entered is -3, and here I am not going to write it as h because this is not hexa, this is a decimal number. You can, if you want to write a hexa number, convert this, that is fd, you can put that fdh. Okay, I am writing it in decimal. And then third step is put 50h into scon. Again, how to do? Use move instruction, move scon hash 50h. So what is happening here? If I put 50h, we are selecting that serial communication in mode 1, and also we are enabling the REN pin. It means it is ready to transfer. Now start the timer. So how to start this timer? By making tr1 equal to 1. So you just need to set it. So set bit setb tr1. So this is called bit instruction. That instruction will affect only one particular bit, and this tcon register is a bit register. So we can select this tr1 and make it set. So that is going to become high. Now the timer is start, means the bus is ready to run. Only the thing you need to enter the passenger, push the passenger into the bus. Okay. So before that, just let's open the door. So how to open the door? Just make it clear. Clear that tf1. So how to clear? Again tf1, that is using an instruction called clr tf1. I'm just making the tf1 register 0. Okay, making sure that we are checking for that tf1 later. So now I'm making it 0, and then give the data into S buffer. So what is our first data? I need to move y serially. So when you put the data in S buffer, it will transfer serially and through P3.1. Okay, so put that y into S buffer. How to do that? Again, move S buffer SBUF comma y. But when we give the character, it has to be given hash double quote, right? So this is how we need to give the character. Now after giving this, the timer is already started, so it will start transferring. So meanwhile, what you need to do, you have to check for this tf1. So for that, what we do, check tf1. That is the step number 7. So we use jnb tf1 and put some label like I will put here. And where should I jump? See, jump if there is no bit. If there is no bit in this tf1, you jump. Where should I jump? To this label. And where should I give that label? What do you need to do? I don't want to go anywhere. I want to be in the same line. What I do, I write the same label here. Okay. So if there is no bit, it will be in this loop only. So it will be in this line until and unless this tf1 becomes high. And when that tf1 will be high, it indicates that the y, the character what we have written here, which is being given in S buffer, is transferred completely. Now you can go for another transfer. Okay. So once this becomes high, you will come out of this loop because this is going to be failed. Jump if no bit. Now if it is bit, it will come out. So what is next? Here they have given one more task. Put send n through port 0. Connect it to LCD display. So for port 0, we have parallel LCD display here. So just put n into that port 0. Then it will transfer parallelly. It is not serial. If it was a serial, then you have to use only this pin only, P3.1. But they have mentioned that it has to be sent through port 0. So what you need to do is, you just need to put N into port 0. So for that, what you use, the line used, move port 0, comma hash N. So this is the character I want to put it into port 0. Right. So when I put it into port 0, this is no way serial communication here. This is a parallel communication. See, LCD display will be connected, all 8 pins will be connected to LCD display. Whenever I put N into this, it will be displayed on the LCD display. For this, I don't need S buffer. For this, I don't need the timer to be start. This is a parallel task. Okay, in this question, they are using serial communication as well as the parallel. Okay, so this kind of questions you may get. So this is another task. This is another task. Okay, so this task is done after that serial transfer has been done. And after this, what you need to do? They told you to repeat it continuously. Repeat this continuously. Okay, so now keep one point in your mind. TF1 is high because the data is transferred. Now before going to repeat this process, first you have to clear that TF1. So that clear TF1 is already here. So what this statement says, if you want to repeat the transferring of data, jump to step 5. So that is clear TF1. So you have to jump back here. So how to jump? Now there is no condition. Means they are not mentioned that you have to repeat it for 1 time or 2 times. So there is no condition. Continuously you have to do. So unconditional jump, that is short jump, SJMP. Short jump like up. I will just write a label up. And where you have to jump? To step number 5 where we are clearing it. So this is the instruction where we are clearing TF1. Up. So we'll jump to this line. Again TF1 will become 0. Now Y is again given to S buffer. It will be transferring and it will be waiting for that to transfer. Once TF1 become high, it will come out and again N will be given to port 0. It will be displayed. Again it will jump back here. Clear TF1, so it will be repeated. It's the same question. If they ask you to do it for 10 times, then what you need to put? You have to say D, J and Z and take one register, assign that as 10 and decrement that register unless it becomes 0, it will be repeating. After 0, it will come out. Okay. So that is how small changes they can do in the questions. I hope this program is very clear for you. If it is clear and if it is understood, then please mention it in a comment and also subscribe to my channel, and especially the members, you join to my channel if you want to get more programming videos like this. Don't forget to join. You even inform your friends to join my channel. Thank you.